Hi, I'm Adam, creator of SUMO.
Hello, I'm Jenny, student of SUMO.
We're going to do yet another podcast. This is a follow-up to the last one we posted. So we were talking about definitions for following. And maybe I should say, while we were offline, we had a little discussion about this issue about do we want sentient agents or cognitive agents. So I thought I'd really have a little discussion emphasis at this point. So the issue was that certain facts in SUMO, certain definitions, such as the definition of intentional process, requires that we have a cognitive agent and not a sentient agent. So let me just bring that back up so we kind of remind ourselves. So let's look up cognitive agent. There we go. And yet we thought, well, gosh, what about dogs? And then that was a funny boundary case. So I thought, let's take this as far as it'll go. Let's talk about ants. Okay, ants follow one another. They sure look like they're following one another when they're going to and from their ant hills. But if we are requiring that it be an intentional process, then we can't have ants, because ants aren't cognitive agents. And so that made me think, it reminded me of this issue that's really important while working on SUMO, which is that the terms in SUMO, we give them names from language, but they're not words, and they don't have to match the words that we know and our intuitions about those words. But language is not a formal theory, and we shouldn't try to make it a formal theory. It's nice when we can get really close and have terms in SUMO that match very well to words in English or any other language. But in this case, I don't think it matches very well. We humans, when we're speaking English, use following in a very vague way. And that's just like when we started this discussion, we talk about one pool ball following another, even though there's no sense of agency. And so I was thinking that ants following one another is not too much different, maybe, than pool balls following one another on a path. The ants are following, have an instinctual behavior. They're not aware of what's in front of them in any cognitive sense. And so we shouldn't try to make following mirror our informal use in English of the word following. I think we're fine just defining following, the formal term in SUMO, not the English word, as being something that only occurs amongst cognitive agents that can actually think and know something.
But I do have a little problem. For example, you have a dog following, for example, so the police using a dog as a drug detective agent. The dog is following some kind of smell, and then
yeah, you in
leading.
English would call that following, but I'm saying that to make things clear and consistent in SUMO, make the theory clear and defensible and objective, we're going to exclude that. At a different time, we can go about creating something that's like an instinctual following that would have a different sort of definition. But for now, I'm suggesting that for this exercise, for defining following, we define it as something that occurs strictly from a cognitive agent.
Okay, that's fine, because what SUMO is, you define what it is, and then you just write the axiom.
Right. Okay. So we'll go ahead and do that. So let's start doing some typing. And here's another point. We use the Sigma browser when we're trying to find out what's already there, but creation of definitions in SUMO is done in a text editor. It's programming, and programming is done in a text editor, not some tool, although tools can help.
Okay.
So why don't we start out with
some
basic stuff. So we have maybe a subclass statement, right?
Right.
All right. So subclass, we'll call it following.
So remember, we have to put the capital letter on the first letter of following, because it's a process.
Because it's a term that's not a relation.
It's not a relation.
Right. So subclass is relation, it gets a lowercase, and following is not a relation, and it gets an uppercase letter.
Right.
Okay. And so what is following? Did we
Following,
decide?
it's a subclass of intentional process.
Okay. Good. What else did we determined it was?
It's also, well, it's a subprocess of translation, but do we need to specify it being subclass of motion?
We talked about it being a subclass of translocation.
Yeah.
Okay, there we go. Now, actually, one thing we didn't do on paper, we were making some notes earlier. We didn't do a documentation string. So we should make following. Let's see. We want to say something in the English language.
Yes.
That following is an intentional
Process.
translocation. Oh yeah, let's make it. Oops. Let's do this.
I have a question.
Okay, just a moment. Let's finish this thought. Intentional process of translocation, where one entity attempts to ascertain the location of another. Okay? That's a good start, at least.
Yeah.
What was your question?
Well, I noticed you typed some ampersand and percentage.
Yeah, so these are little hyperlink characters. They tell the Sigma browser that what follows is a SUMO term that can be hyperlinked. So let's take a look at an example of that. So see here all these things that are highlighted in the comment string. In the original, there would be a little ampersand percent in there, and that allows, it's kind of a hypertext markup that allows Sigma to make things easier on us by hyperlinking.
I see. Thank you.
Okay. And let's also, another thing we should do is a term format expression.
Right.
So that we have a sort of pretty print version of following.
Right.
Now, in this case, for English, it's pretty easy. It's just following lowercase.
Right. That's the English word.
Okay. Great. So now this is sort of the preamble. We've got the basic taxonomic information. We got a documentation string. Now we can start creating some rules that really are the meat of the definition of these things.
Okay.
So we want to say, let's start out, let's say, if we have a following, right?
An instance
of a following.
A process of following.
Yeah.
Then there exists
a few different things.
They are called variables.
Variables, yeah. We're going to do a variables, and it's more formally a quantifier list. Exists as an existential quantifier.
Right.
So we've got a cheat sheet in front of us, of course, but let's go through this a little bit more like we were starting it from scratch to help people understand what the process is. Because we're not going to know what our variables are at first. We're sort of sketching this as we go along. So what happens in a following? We've got a few things going on.
We have two translocation.
Okay, so we've got our pursuer moving from one location to another in order to keep tabs on the pursued entity that's also moving from one location to another. So we get two translocations. So let's call them T1
translocation
and T2.
So that's the process. Okay, and they are sub-process.
Yeah, very important. So here's a case of where we've got one process that includes some others. Right? So the whole thing is a following, and following necessarily includes these two entities marching along, one keeping track of the other.
So we call them sub-processes.
Sub-processes. And in most of these sorts of relations, the smaller thing, the contained thing, goes first is a good way to remember a guideline for the argument order. So T1 is the thing that's underneath F.
Right.
Sub-process T2F. Okay?
Right. Then we have the one who follows somebody, the agent.
Okay, so let's talk about the the agent of the following, let's call that person, that entity A1. Okay, so that A1 got one of these translocations. So the agent of F, the following, is A1. The agent of, let's call it T1, is also A1.
Okay.
Helps keep them straight. And then we got the person, that's the subject. So we've got the patient of the following, let's call A2, the person being followed.
It's also an agent of another process.
Yeah, he's got, he or she has his or her own translocation process. He's the agent of. He's running along. He's the object. So A2 is under T2.
But how comes A?
Oh, the other way around. This should be, yeah, argument order is really important. So in all these case roles, the process goes first. Okay, great.
Okay, the first thing we discover is the two processes overlap each other.
They overlap, yeah.
Do we have a term
Yes,
in SUMO?
very important. Let's check on overlaps, because I'm not actually sure if it's overlaps or temporally overlaps. So let's look at that.
I find it, the Signal website is very important when I'm doing SUMO. If there's anything I don't understand, I'll just go to the website and search for examples or definition.
Right, yeah, so here we have overlaps temporally. Great, that's what we actually want. Two intervals have a time interval that's a common part. They overlap temporally. Great. So overlaps temporally. T1 and T2. Oh, now let's see. Let's look at the argument types for overlaps temporally. Time interval. Except these translocations are not time intervals, they're processes. So to get the time interval of a process out of a process, we need this function called when
Function.
fun.
Oh.
Okay, so when fun takes a physical thing, and a process is a physical thing,
Yeah.
and returns or has the range of a time interval.
Right.
Time interval, notice how time interval now maps the required argument type for overlaps temporally.
So how do we get to do that?
So we do this. And we can reformat a little bit for clarity. So when fun, and when fun, two.
Right.
And we'll close the parentheses. Okay, so now we've talked about their temporal overlap. We've got our agent and patient expressions. Now here's what comes, I'd say, the hard part of it.
Yes.
Right, so we want to talk about the fact that right now as it stands, we could have A1 following A2 or A2 following A1. There's nothing that constrains us.
No.
We've got to have this sort of precedence of causality.
Right.
That the fact that my target is moving means that I move. I move as a result so that I can keep him in my sights.
Right.
So what we think we want to say is we want to talk about what are my wishes? What's the objective of the person who's doing the following?
Knowing the location, whereabouts of the one being followed.
Right, because we're not necessarily catching, right? We're not grabbing the guy. It's not an apprehension like a police chase. It's just a following. So, and following requires that if you're going to follow somebody, you have to know where he is. So
Yes.
I think, there are many things that could be said about more specific actions, but the only thing that's definite about a following is that you want to know the location of the other guy.
Maybe from time to time you don't know, but you don't lose track.
Yeah, so we can say that at least that's your desire, and
Right.
that it holds during the whole period of the following, that that's what you want, is you want to be aware of the location.
Yes. At the point you cannot know, then you give up.
Yeah, if you can't know, then I suppose the following would be done. But if
Yes.
you can know, if there's a chance, that's your desire, and you
Yeah.
keep moving.
Right.
All right.
So we have.
Let's say it. Yeah, we have holds during. That's how we temporally quantify something. And so we're going to say that it holds during this period of f, the following.
Right.
And so we said that our agent wants something to be true.
Yes.
So this is a good chance to go back to sigma. How do we say that he wants something? Let's see, so let's look at wants.
Once you have a cognitive agent.
The object is desired. So a physical thing desired by the agent. But there's not a physical thing that the agent wants. It wants a situation. It wants to know a location. That's not an
Right.
object. So here's a related concept to wants. Desires.
Desire. Let's
Yeah,
look at desire then.
Yeah. Desires takes a formula.
What
Okay.
exactly is a formula? I've been trying.
Everything that we're writing here, these are formulas.
Right.
Yeah. And so we're going to talk about desiring a state of the world, as it were,
Right.
that's described by or defined by a formula.
Right.
Okay, so we can talk about our agent wanting a formula. So let's try desires. And
Whose
our-
desire?
the desire is of the agent of the following.
A1 then.
A1. Okay, and so what does he desire?
To know.
He wants to know something. Well, let's find out. Do we have a predicate for that? Do we have something about knowing? Knows. Hey, look at that. We do. Cognitive agent knows a formula.
Right.
Okay. So, I'll say knows, and again, this is about A1. He desires that he knows that
Know what?
what? We want to know, what does he want to know?
Location.
The location of this other entity.
So do
Okay.
we have in SUMO terms something called locate?
A location. Well, I know what it is, but this is a good chance to show. If you typed in location, you'd get a list, and oh, in fact, what you want is located.
Right.
Okay.
But not locating, but located.
Yeah. Because we want to know a fact. We don't want to know a process of locating. We want to know a fact of being located. And located is a relationship between
Right.
two objects, or two physical things, really.
Right.
Okay, so we want to have located. Oh, and what's the argument order? Okay, it means that object 1 is partly located at object 2. Okay, so that also keeps with the theme of argument order, that the small thing goes first. So the small thing in this case is
Okay.
A2,
A2.
and that there's some location x.
That we don't know.
Okay, so close paren, close paren, close paren, close paren, close paren, close paren. Okay, that's a fairly complex axiom for this. This is a hard example. Let's see, now maybe we have one more thing that we can talk about.
Yes, because last time in our podcast we talked about how do you distinguish between following and leading.
Right,
You also have two sub-processes of translocation.
okay. So let's specify something else about...
So in this sense, we have to define two axioms.
Yeah, we're going to have two axioms on following. Now maybe there are more things we can say.
Okay.
I think so far in our discussions offline, we've only thought of these two main things that we can say in addition to the taxonomic information.
Okay.
So let's say, right, we have more complex things. We need a conjunction here for our antecedent. We're going to say that we have an instance f following, right, just like in the beginning. And then we're going to need to talk about a lot of the things we did in the consequent here. We're going to talk about the motion of one of our entities is going to cause or trigger the motion of the other entity, right? Every time my target moves, I want to move with him so that I
Okay.
can fulfill this desire of knowing where he's located. So his motion causes my motion if I'm the guy who's chasing.
Right.
So that means we've got to say that we have these two instances of translocation, their sub-processes, an agent, a patient, and all this stuff that we just said above is going to be part of our conditions here our preconditions here, right? Our antecedent this time. It's a little different setup. Right? All these things we've got to call out.
Okay.
Right? And if we have all of this stuff, right, about our following, about our translocations,
Then
then what do we have?
then we would need to say one motion or one translocation cause the other
Causes
one
the
to
other
happen.
one. Right. Okay, so for that we have a SUMO relation called causes. Let's take a quick look at that. Causes. Causes is a relationship between two instances of processes.
Great.
So that's exactly what we need. So
Brilliant.
one process causes another. So we'll say causes, and which process causes the other?
The second process, T2 causes T1.
Right. T2 is the guy who's being followed.
Yeah.
Okay. So there we go. That's it. That looks to me like a reasonable definition of what following is, or
Wow.
one idea of what following is. So good job.
Thank you.
Yeah, thank you. So we'll close it for now, and hope this has been helpful. Thanks.
Thank you.